I apa tadi saya macam dengar macam ada suara. Ada soalan ke? Okay. Alright. Okay, saya dah record. Okay, change of variables. If you remember from your calculus 1, so MTH 300, you say, for example, if I have integration from, let's say, 0 to 1, so that's the 0, maybe 0 to pi over 2. And then I have cosine of x squared x dx, something like that. Okay, so awak buat macam mana? How did you approach this problem? So what you did is you say u equals to x squared, therefore du equals to x dx. And then in this case, you have the x dx is just 1 over 2 du equals to x of dx. And then you also say that when u equals to 0, because this is the boundary, u equals x equals to 0, meaning that u also 0. When x equals to pi half, u means pi squared over 4. So this is the boundary. So actually you are doing a change of variable without realizing that you did it before. Okay, so and then the same thing, what we did for polar coordinate, from rectangular, from x to y, in our, this is in 1-dimensional, and then in 2-dimensional, we have changed from xy plane to r theta plane. And then we get, for example, if I have integrate from x to a to b, y from c to d, and then I have f x y dy dx. So when you do the change of variable, you say theta goes from alpha to beta. Dia jadi bulat dah pula. Sorry about that. So it goes from alpha to beta, and then c goes from the y direction goes from maybe function of h1 of theta, and then function of h2 of theta, and then this will be f r cosine theta, r sine theta, r dr d theta. Okay, so this is the same analogy. So meaning that in this case, this is called transformation. So you transform x, y, and it became something like u and v. Same thing, if you do the analogy in one dimension, you say I transform x into u, which is just x squared. So I transform x in terms of u. So in this case, if I want to do general part, so in general, I say for 1-dimensional, so I say x, x equals to some function of u. And then I said x prime equals to f prime of u. Times what? Times u. The thing inside f prime and then maybe u prime, something like that. Okay, so this is the definition of f prime, and then u prime as well. You need to do the whole thing, the inside derivative and then the outside derivatives. Same thing for one dimension. Sorry, same thing for two dimension. We have, in this case, u and v from x to u and y to v. Okay, so in this case, this is polar coordinate. Okay, now we want to go for general case. It might not be polar coordinate, it might be from other states. So in one dimension, I always want to go back between one variable and then two variable, because I want you to understand the your basic knowledge, and you just extend it to two dimension, two variables. Okay, in one dimension, what you did was change of variables. So I just write COV, so meaning this is change of variables. Okay, what you did was in one line, only in x direction. Okay, and then x becomes u. So you transform x becomes u. And then after you do the calculation, so you change back this u line into x line. So meaning that in this case, if I want to get u, t x equals to u. So this is the change of variable. So I get tx equals to u. And then after I get the calculation, I say, all right, so I want to get x. X now becomes t inverse u. So meaning that in this case, if I want to have these points, and then it corresponds to that point. Let's say this is A1. A1 goes to alpha 1. And then I have another point, A2, and then this one goes to alpha 2. Okay, let's say if I get the value of alpha 2, sorry, alpha 1, and then I want to go back to x, it only corresponds to one value. Let's say maybe this one A1 prime, not prime, maybe we can use another notation, big A1. Okay, same thing for, let's say my output is right here, alpha 2, and then this corresponds to big A of 2 in x axis. Okay, so meaning that t is 1 to 1. Meaning what? Meaning what? This one is t is reversible. Let's say t is not 1 to 1. What you do in math 300 is that you need to define if it's not, then you need to define your domain, right? For example, if I have example, if I have this one, y equals to x squared. Okay, so this function is not one-to-one. This is not one-to-one. Okay, since this is not one-to-one, I need to define, you need to set x goes from, let's say, 0 to positive infinity. So now I get one-to-one. Same thing for this one, change of variables. Okay, so for this case, two-dimensional case, the same thing is going to happen. So if I have 2D change of variables, okay, I want to have this line x, and then I need to have this line y. So I'm changing I'm changing the region, okay, y, because I have x and y space, transformation of x and y space into into u and v space. So x and y plane goes to u and v plane. It's not always u and v. You can have st, p, q, or something else. But uv uv is mostly used because if we increase the dimension, it will be uvw. And then if I have st, st usually refers to any space that related with time. So it's better to go like Cartesian coordinate into general coordinate u and v, and then anything related to time we can use s and t, and so on. So maybe you can also use other Greek alphabet, alpha, beta, and theta. So alpha, beta, and theta usually for what? Usually for any coordinate that is related with angles. You have pi, you have anything, cosine and sine, so a square or something like that. So that part is reserved to that variables, and this part is usually reserved. This is the convention, so it's easy. So, but if you see any other letters, don't be confused. Okay, so for example, this one, I want, if I have some kind of parallelogram, something like this. So you can see that this one is harder to do compared to if I have a rectangle. So I want to change. So I want to change from parallel region, this is R, parallel, to S region. So this region. Because why? Because this one is line equation, and this one is also line equation, but this one is constant on all sides. So this is also constant, this is constant. So you just want to change the region. Okay, let's see some example. Some examples in 2D. Okay, before that, I just want to let you know that for example, if I have also from, let's say this graph, okay, let's say this one is in XY direction. And then I want to change it into polar coordinate, the same thing. What I did was, so for example, if I have this region, or maybe not that region, some kind of this, something like that. So in polar coordinate, perhaps it looks something like something like this. So it's easy because why? Because now this is constant. So let's say this is in R, and then this is S. Okay, so alpha is constant. Let's say this is alpha, alpha, and then this is beta, and this is R. Only R is single. Okay, so from this XY to alpha and theta. Sorry, so theta and R, radius R. Actually, this one is should not be in straight line. It should be in like some kind of circle or something like that. So actually, let me rewrite this one. Actually, in polar coordinate, it looks like a circle. Everything is in circle. Something like this. So, oh, so everything is in circle. It's not to scale. Sorry. So this is the radius. So this is the radius, and this is your um, theta. The radius, sorry, the radius is not like that. It should be something like this. Okay, so this is the R. Should be like that. Okay. So example. Okay, let's see. It says that sketch the region. Sketch the region for transformation of of the region. Sketch the region for transformation of region S. So S is given. Sorry, sketch the region for transformation region S to R when S is from UV, when U is between 0 and 1, and then V is between 0 and 1. And then it's given the transformation is X equals to U squared minus V squared, and then Y is equals to 2UV. Okay, so first thing first is we sketch the original region. We can sketch the original region first. So the original region is in U and V. Okay, and then U goes from 0 to 1. So this is 0. Let's say this is 1. So this is 1. This is 0. So this part. And then V is also 0 to 1. So this part. So 0 to 1, this line. So meaning that it goes from this line and then also on vertical side. So this whole, so this is the region S. So I want to change from S to R in Cartesian coordinate. Okay, actually, this is easy. I mean, like, if you see a rectangular region like this, you don't have to do the transformation. But if you see some weird transformation, then you have to do some weird region, then you can do the transformation. So I want to transform this into anything in X and Y axis. Okay, so something like that. Okay, let's see. Let's try to do it one by one. Okay, the thing about the key point about transformation is that if you have four sides, four sides, the transformation is also should be four sides. So the region is also covered by four sides. Transformation also. By the way, apa maksud transformation? Awak tengok cerita Transformer kan? Sebenarnya apa maksud transformation?
Berubah.
Berubah bukan ke change ke?
Bertukar.
Perubahan.
Okay, sebenarnya mungkin awak dah dapat sikit-sikit tu. Trends tu yang maksud bertukar daripada sini ke sini. From 1 to 2, let's say. From 1 to 2 trends. Dia bertukar daripada tu. Formation, sebab kita ada banyak, kalau awak perasan bahasa Inggeris ni dia ada banyak transport, transformation, trans apa lagi? Trans region, trans apa lagi lah, macam-macam lah trans. So maksudnya contohnya transport, kenapa dia transport? Dia tukar port, dia tukar tempat port. So sebab tu transport tu khas untuk macam apa ni kereta apa semua, sebab dia transport daripada sini, daripada perubahan tempat daripada sini ke sini. So transformation, transformer, kalau awak tengok transformer tu dia bertukar bentuk, transform, bertukar bentuk. Transformer tu dia bertukar bentuk daripada kereta kepada robot. Tapi dia benda yang sama. Sama juga dengan yang ni, dengan kita punya ni. So dia bertukar bentuk saja. Tapi dia punya, sebab tu saya kata dia punya, if it has four sides, it should be, the transform should also be four sides. Kemungkinan kita tak nampak tapi dia ada kat situ. Dia tak berubah benda tu. Apa yang berubah cuma dia punya bentuk saja. So perubahan dia punya apa ni, transformation tu maksudnya perubahan dari segi bentuk. Macam transformer, dia perubahan bentuk tapi dia adalah benda yang sama. Macam yang ni dia adalah region S, bentuk dia kepada region S tapi dia ada sides yang sama. Okay, that's one, just the definition, just for your basic knowledge. Okay, let's see this one. Let's try to label and then try to transform one side to another side. Okay, let's see, I label this as L1 for line number 1, L2, and then L3, L4. Okay, saya nak ubah line yang pertama dulu, the first line, into X and Y axis. Okay, let's look at on L1. So if you can see that L1, U equals to in between 0 to 1. Okay, and then V is the line at 0. V is this line. Okay, so this is V equals to 0. Okay, so now let's look at the formula. Formula said that X equals to U squared minus V squared, and then Y equals to 2UV. Okay, now what's the easiest part to substitute? So you can substitute V equals to 0. So you substitute V equals to 0. So meaning that I have X equals to U squared, and then Y equals to 0. So Y equals to 0, this is one line. So we have Y equals to 0, one line. And then you can see that when try to look at your domain from 0 to 1. So if look at the domain, U is less than 1 between 0 to 1. And then therefore, if I want to take it into X axis, this is U squared. So meaning that 0 squared and then 1 squared. So X is between that. So this is meaning that X is between 0 and 1. So you go back to your Cartesian coordinate. Let's say this is 1 and this is 0. So X goes from 0 to 1, and then Y is the line 0. So Y is the line 0 is right here. Okay, so this is Y equals to 0, and then X goes to from 0 to 1. So this is this part. So that line. So let's try to give the label. So let's say this is L of 1. So this is the transform for L1 into L1. Okay, now let's look at on second line, which is when U equals to 1, U equals to 1 on this part, U equals to 1. Let's use a different color. So this is the second line. U equals to 1. And then V goes from 0 to 1. So in this case, U equals to 1. And then V goes from 0 to 1. Okay, now what happened to our X and Y? Okay, so X equals to 1 minus V squared. I just substitute right away. And then Y equals to U is 1 to U. Sorry, there's a mistake over there. Should be to V, because V is U is 1. All right, so meaning that this looks like you can substitute V inside, so that the equation is in between X and Y. So I can say Y equals to 2V. So Y equals to 2V, and then we can say X equals to 1 minus 2V squared. Therefore, X equals to 1 minus 4v, sorry, 4y. Salah. 1 over y over 2 squared, because this one is v is 1 over 2y. So I've substitute this into v squared, not this one. Okay, so it becomes 1/4 of y squared. Okay, so this is like a parabola. This is what? This is a parabola. So how does it looks like? Remember that u1, v goes from 0 to 1. Okay, so v goes from 0 to 1, meaning that I need to specify my y-axis. So y is between, so 0 to v to 1. So y is 2v, 2 times 0, in between 2 times 1. So y in between 0 and 2. So in that case, let's see that it will cross at x equals to 1. Then this is 2. Let's say this is 2. So it looks like a parabola. It cross like that. Oh, I don't want to use this color. Let's use the yellow color. Okay. So this is the transformation for L2. So this part. Okay, any questions so far? From L1 and L2 in UV to XY. Okay, now let's, I think this is straightforward, just do the math. Okay, let's look at on line L3. Where is line L3? L3 is the top part. Let's use what color? Let's use blue. Okay, so this is L3. So L3 is when V equals to 1. And then U goes from 0 to 1. So it's the opposite of L1. Okay, let's write them back. So V equals to 1, and then U in between 0 to 1. Okay, what happened to X? So X is U squared minus 1. Because we have U squared minus V squared. V squared is 1. And then I have Y equals to 2 of U. And therefore, U equals to 1/2 of Y. So you substitute Y 1/2 Y for 2, and then you can get, so this means that X equals to Y squared over 4 minus 1. Okay, so Y squared is, this is also a parabola. You can see that this is the opposite of our previous parabola. So that one is on this side, and that one is on the other side. Okay, and then what happened to the range for Y? Let's see. U goes from 0 to 1, and therefore Y goes from 2 of U, 2 times 0, in between 2 times 1. So Y is between 0 and 2. Okay, so it's the same thing, except that it is on the opposite side. 1, 2, 3, I think it's on, let's say this is minus 1. Okay, why minus? Because you can see that if y is less than 2, the -1 will be bigger part. So this is, let's use it, this line. Okay. So this is this line, which is L3. And then the last part is L4. L4 is this line. Which is u equals to 0, and then v is between 1 and 0. Okay, so now let's look at the effect of that. On L4, u equals to 0, v is between 0 and 1. Okay, so u equals to 0. So x is minus v squared because u is 0, and then y is 0. So this is like a line for y equals 0. And then let's look at the results of the range for x. So v is between 0 and 1. So x is what? Minus v, minus 0. Sorry, this is minus 0 squared, and then this is will be minus 1 squared. So x is between 0 and minus 1. That's not should not be like that. So you need to switch the part. It will be minus 1 to x and then 0. So this is okay, but this is on negative part. Let's just flip that. So x between minus 1 and 0, y equals to 0. All right, so if you look at this one, x between minus 1 and 0, this line, and given also by y equals to 0. So we have this L4. So you can see that L1, L2, L3, L4, four sides, and then this correspond to the 4 sides in UV direction, UV plane. Okay, so this is the transform region S. Sorry, this is transform region R. So that's how you do sketch the region. All right, I have another sketching region, but I don't think we are going to have enough time for that, because after this I'm going to give you the quiz for that. All right, let's take a day. So stop recording.